Doctor, we can't hear you.
Sorry, my bad. So let me restart everything. Okay. All right. All right. So let us start. Actually, I think I mistakenly kept it on mute, and then I, I was just. Anyways, all right. So in the last class, we started this. In the last class, we were in this chapter of data understanding and preparation, and we have covered bullet number 1 and bullet number 2 in the last class. And in the last class, we were in this case study 1. Okay. So today, hopefully, we'll finish this case study, and if we have time, we will discuss maybe the topics from the previous chapters if there are any doubts or questions. Now, in the last class specifically, we have looked or we have talked about data pre-processing. Data pre-processing is very crucial because any real world data could be dirty, and then we need to do some pre-processing. It may not be dirty, and we'll see what is the meaning of that. Okay. But it may not be always the case, but still we need to do some pre-processing. What are the things involved in pre-processing? Well, we need some cleaning and some transformation. So data scrubbing or cleaning is one of the, you can say, tasks of data pre-processing. And the other task is data manipulation or transformation. Now, if you focus on data cleaning, which is basically for the dirty data, you have, three, you can say, reasons why you need to do the cleaning. Either the data could be incomplete. That is, the data could be missing. You could have empty values. You could have NaN values. Then we should know how to handle it. The data either could be outliers. It could be noise. And then we need to have some way to handle the noise. Or the data could be inconsistent. Okay. The data could be inconsistent. And then we need to know some ways to handle it. In the last class, we have seen different reasons why the data could be incomplete, or why you could have noise, or why it could be inconsistent. Most of them could be, simple accidental errors that happen while the data was recorded or while the data was entered. Or sometimes you have incomplete because the data wasn't available, or maybe somebody left it because it was obvious. Okay, and all these things, all these three things, okay, all these three things makes the data dirty. Okay, all these three things. Sorry. So all these three things makes the data dirty. Okay. Now, when you have incomplete data or when you have missing values, then we should know how to handle it. In the last class, we have learned that when you have incomplete values, you could use the methods like dot. Well, how to handle the incomplete values? Either you can just ignore it. You can just completely ignore it, or you try to use some global constant, some well-known value, or try to interpret the value. Okay, interpret or impute, or maybe let's use the words that we used in the class. So we try to either impute or use some sort of inference. Okay, so maybe infer is okay. So either you import or infer the values. Essentially, what we mean is either you kick out those values from the data from the further analysis, or you or you try to fill the missing values by some of these methods. Now, in the last class, we have seen a method called What is the method to give some value to the missing value? Yeah, fill NA. That's the method that will fill the NA values. So you select a column. If you use for entire data frame, you can fill all the NaN values with a given value. But usually you select a column. You select a column of the data frame. Okay, you select a column. And for that column, you fill the value. And that value will be filled. Okay. Sometimes you don't want to fill, maybe you don't know what's the best value. So then what you do is for those columns, again, you can do it for the entire data, but usually you do it for the row or columns. Okay. You use a method which is drop NA. Okay. Drop NA. And then here you could use access a keyword to drop the row or the columns. So this one is for the entire data frame. For the entire data frame, you try to look at the rows or columns and you drop. Drop means remove them from the analysis. Okay. It could be permanent if you say in place equals to true option. Otherwise, it will be temporary just for the printing. You could also give your criteria. So you have another important argument here. Do you remember what's the other important argument? How? And this will tell you whether you're dropping a row or column. Again, row column is selected by axis. And how will tell you whether you have one or many. Okay, any, yeah, which is for one or many, and all, which means all of them are NaN. Okay, and you can use these two arguments to delete the NaN rows or columns. Okay, axis equals to 0 will delete the rows. Axis equals to 1 will delete the columns. So that is how you handle the incomplete or missing values. Now, what about the noise? For the noise, you should have some filter mechanisms. Somebody should give you a filter. Okay, somebody should give you a filter, or somebody should give you a fix. Okay, what to do? They should give you some condition. For example, in this case study 1, we have seen any negative value, you convert it to positive value by absolute function, absolute value function. So that's a fix that was given to us to get rid of noise. Sometimes you have filter. For example, you could say, anybody getting a value in a particular column, let's say in column for, let's say, GPA, anybody getting 5 is a noise, is outlier. And how to filter it out? Well, we can say, somebody might have entered it incorrectly and it could have been 4. So that could be the fix. So somebody should give us what we mean by outlier and then how to fix it. Okay, that's how it should be in, at least in this course. But for a real case study, maybe you have to think about what is the filter and how to fix it. Usually the filter and the criteria that will tell whether it's a noise or not will come from the domain expert. For example, for GPA, we all of us know what GPA is, especially with respect to KFUPM. So if anybody gets GPA, we know it's a value between 0 and 4, most probably between 2 and 4. Okay, so that's what we know. So that's the domain knowledge. So based on that, you can create a filter. So whenever you have noise, somebody should give you a filter and the corresponding way to fix it. And then finally, the inconsistencies. Inconsistencies are usually occurring because of different units or different formats. Okay, and for inconsistency, mostly you have to reformat the data. Either you scale it out or either you scale the data or format the data. Maybe you have to do some string manipulation, and this is where you have to use the methods, mostly the lambda method with the string and the, let me write it here. You have to use this casting, for example, int, float, or string. Sometimes data is read in a different style and maybe is asked in a different style. So you have to reformat it, or you have to use dot replace to replace some of the, the elements from the data, or you could also use dot strip to get rid of spaces and things like that. So all this formatting, anything that has to do with the formatting or scaling, also plus scaling is part of this inconsistent data. So we have seen all these things, and I believe we applied almost all these things in the case study 1. So when we continue with the case study 1, we will see these things, okay? And once we are done with the case study 2, case study 1, then we move to the next case study, which is related to the transformation, okay? So let us quickly finish case study 1, and then I will come back and revise what we have in the transformation, and then we'll go to case study 2, okay? So before I proceed to case study 1, do you have any doubts or questions here in these topics? Any doubts, any questions? Drop will drop based on your condition, whatever condition you give. Drop NA is specifically to drop based on the null or the NaN values. Okay, so drop in general can drop any row or column based on your uh, condition, based on your requirements. Drop NA will drop those rows or columns that contain NaN values. How many NaN values? It could be one or many, or it could be all. And that's the criteria you should be, using in how keyword. Is that clear? All right. Any other question? Okay, so if you have no other questions, let us go to the case study that we have started in the last class. This was a case study. That's the data set we were using. And we have answered bullet number 2 and 3. And then we also did bullet number 3, which is to resolve inconsistency. The only inconsistency here was the population should be numeric, but it was read as object. Why? Because of this commas. So because of the commas, software Python understood it could be a string. Okay, so we use the apply lambda approach, and then we use the int typecasting to convert from the string to integers, and then it is now int. Okay, all right, and then just can anybody remind me, have we started this bullet number 4 and we finished it, or we were in about to finish? Anybody in the class? Sorry?
We finished this.
Okay, that's good. So then in bullet number 4, because I have 2 classes consecutively, and sometimes I forget where I stopped.
Even the next one, we finished it.
Oh, that's good. Okay. So yeah, so maybe in the other section now, it's only 4. So we have seen this in the last class. We have seen how to clean the data, and for this we had 3 options. So one option was to filter or smooth noisy data. What was a filter and what was a fix? It was that filter was any negative numeric value. So whenever you see a negative numeric value, you should be cautious, because it is something that's noise. It is something that is not acceptable. And the fix was to replace it by the absolute value. So how did we do? We identified all those columns that are numerical. So here you see these are the list of the names of the columns that are of numerical type. So you can use select D types and exclude object or include number if you want to use include. So you get those column names that are for numeric, and for those numeric columns we are making this check. Okay. We are doing the lambda function. I think in the discussion we said we can also use it like this, straightforward. For every value, make it absolute. Now, this is one style, and the other style is this. There is a small advantage of this style, which is if this function takes time, okay, then doing it for all the values will be unnecessary wastage of time. You can just have a small check, and you can say if it is greater than 0, don't do anything, just return whatever you have. If it is less than 0, then apply this function. So it will save some time. For the absolute value function, I hardly see there is a difference. But yeah, if you have a complicated function here that takes some time, then maybe this will save some time for you. And then we have seen here, there was a, let me show here. There was some negative value. Okay, here. Okay, 6 and male life. Okay. And now after this method, after this code, you see 6 and under male life, it will be converted to non-negative or positive value. Okay. Now we have another case of cleaning where you have to handle the missing data. So to handle missing data, either we can ignore it, you can drop, or we can fill it with some value. So here in this example, we have seen how we can fill based on the requirement. So what was the requirement? Requirement was if you have a missing value, then fill it with the mean for the numeric column. So for the numeric column, any missing value, you fill the mean, you fill it with the mean of that column. And for non-numeric data, you fill it with the mode of that column. So that's what we did here. We have seen how to do it one by one. We have seen first of all how to identify those columns that contain null values. Of course, you can, if the data is small, you can visually see, but in practice, it's not, it is not, practical. You might have too many rows and columns. So for that reason, you could use this dataframe.isna.any to identify those columns that have one or more missing values. And the moment you have those columns, okay, you can iterate over those columns and check based on the type of the column, either you use mean or mode. So in the last class, we have seen how to do it manually, okay, and then we have seen how to do it with a loop. Also, we have discussed these two, actually they are the same, but different styles. We have seen this method drop NA. This drop NA method is to delete NA values, okay, from the data frame. How to delete it? Either you can delete the row or delete the column. You cannot just delete one value, right? Because it's already deleted. NA means it's already missing there, okay? For example, here you have NaN. It means it's missing there. So it's already there. So either you can delete this entire row or this entire column. So how to do that? Well, you could set the axis. If it is axis equals to 1, it will try to delete the column. If axis equals to 0, it will try to delete the row. Now the next question is how to delete, okay? Do you want to delete, for example, let's take this case. When axis equals to 0, it means it's going to delete the rows. So now the next question is how to delete. Should you delete any row containing any NaN value or any missing value, or do you want a row to be deleted when it contains all missing values? So if you write in this keyword how, all, so it will delete those rows that contains all the missing values, okay? But if you don't want to delete only those rows that contain all the missing values, let's say you want to delete all the rows containing any number of missing values, then you can just use any option here, okay? How, any. Sometimes you want to like to have some threshold, and if it contains 1 or 2 missing values, it's fine. But it contains, let's say, 8 or 9, then yes, you want to delete. So for that reason, you can give the threshold option. Threshold option basically tells you how many non-NA, okay, how many non-NA values you would like to see, the minimum number of non-NA values. So if you have 100 rows, okay, let us say you're trying to delete the rows. If you have 100, let us say you're trying to delete rows, okay. Now in a row, you have 100 values, okay, in a given row, you have 100 values. So you could say if you have 97 or more non-NA values, then it's fine to me. Or in other words, if you have 3 or more 3 or less, you can say, inclusive little bit, 3 or less NaN values, it is fine to me. Then you could use the threshold option. And remember, in the threshold option, you give how many non-NA values that you want. Okay, how many non-NA values that you want. And we have discussed this in the last class. Then I think maybe this is the place where we stopped, right? I think this is the place where we stopped in the last class. So the last part of this bullet number 4 is about data wrangling or munging. Okay, the idea is to transform the data for various inconsistencies that happen. For example, here he says one of the data entered the life expectancies, okay, which is one of the columns, maybe this one, okay. In fraction, actually it's all of these, all the three, okay. So it's not clear in the statement, but this is what it says, all these three, okay. So these are all the columns that are related to life expectancies. So he says one of the data collector entered the life expectancies in fraction instead of percentages. Now, if you look at it, you should be able to find that this is one such instance, and maybe this is only the one, okay? But imagine you have data frame with lots of rows and columns. It might be difficult to visually get all those instances. So we would like to come up with an automatic way to identify such instances and then to fix them, okay? All right. To identify those issues, first let us look at the slice of the data that contains those columns only. So I know that these are the columns that I have to focus. So by using this, again, this is not the best way. You could have done in one single shot, but this is one, you can say like systematic way that we have been following. So this selected columns will show only the columns that have that inconsistency, okay? And then if you want to get the data frame with the selected columns, we do it like this, okay? So what do we want now? I want to look at each column and check if the value is less than 1. If it is less than 1, it should be multiplied by 100, okay? So how to do that? How to work on each element of a column? For example, if I want to work on overall life, how to work on this? Anybody in the class? How can I look at each element of this column and check whether it's less than 1 or more than 1?
Can't you use
And if it is more than 1, do something. Sorry?
dot apply
Okay, dot apply.
map?
Well, apply map if you have more than one column. So here only one column.
So apply is
So, yeah. Then what?
and go lambda x.
Okay. Now lambda x means this x will be every element of this column. Okay, starting from this, all the elements of this column. And what do you want to do? You would like to send the same value if x is
Less than 1, then time it by
more than 1. More than 1, because if it is more than 1, it's already in percentage.
Okay.
Otherwise, you would like to multiply that value by 100. Okay. And now you see, I think this was the value that was now updated to 81.9. Now I would like to apply this for all the columns, that I have here in the selected columns, not for just one. Okay. So how to do that? Well, you could say all the columns here, and then you could use apply map. And now you could see that all the ones have been updated. Okay. Any doubts, any questions? Any doubts, any questions? Right? So that's what is being done here. Here we use the apply map over those columns to get this. There's also another idea that can be used here. Either you can use the condition in the lambda function, or you can come up with the mask. For example, I could have created a mask of only those rows that have this issue, and for them I could just multiply it by 100. Okay, so there are two ways. Either you could do the condition inside the lambda function, or create the slice, and for that apply lambda for all, so without condition. Okay, now in this chapter we are focusing on lambda functions with conditions, because sometimes it will be very handy to do the lambda function with conditions than to do the masking. Okay, but I prefer masking more than apply or apply map. Why? Because masking is a vectorized operation, and it will be much faster. If you are talking about efficiency or speed, then masking is much faster than the apply or apply map method. But both, anything that works for us is fine in this course. Okay, so that's the end of this case study 1. Case study 2 is all about data manipulation, data transformation. Okay, and data manipulation transformation, let me just go to this index here, and maybe I could just do a review. Data manipulation or transformation really involves so many things, like you reduce the data size, you have data cube aggregation, dimensionality reduction, and you actually have many things in data transformation. Those things that we are going to focus in this chapter are here. Okay, we are going to talk about encoding, and we are going to talk about scaling. Okay, now these are not the only two things, and in the last class we discussed all the things that we have that can be done under data transformation. Okay, but the most common one that doesn't require any subject knowledge, any domain expert, is encoding and scaling. What is this encoding? The purpose of encoding is you take a categorical column. Okay, you take a categorical column and convert it to numerical or nominal. Now remember, nominal for us, it means something, but for computer, numerical and nominal, they look the same because they are numbers, they are treated the same. So encoding means take a categorical column, okay, or ordinal column. You could also have ordinal, so let me write it here. By the way, categorical is generic, right? Inside categorical, if you want to make it more refined, then yes, you could have ordinal and nominal. Okay, so if you have categorical column, okay, if you have general categorical, just categories, no order in it, and if you want to convert it to numerical, you could do it. Okay, if you have ordinal and you would like to convert it to numerical, you could also do that. If the method says it should be strictly numerical, you could do that. Sometimes the method can take the nominal values as is. It doesn't require it to be converted to numerical. Then you can just use the nominal as is. Okay, so for every categorical data, you could convert it to nominal as well. So essentially, all the data that you have, at least in our course, should be either numerical or nominal for a method to work. Now, if you have categorical data, we convert it to numerical data using, let's use the method here, one-hot encoding. Okay, one-hot encoding to convert categorical data to numerical data. So it will add so many columns, and this conversion will occur. If you have ordinal data, the data has some order. Okay, there is already some order in the data. Then you may not have to go with one-hot encoding. You could do simple label encoding. Okay, simple label encoding and make it numerical. Similarly, if you have categorical data and you want to get nominal data out of it, you can do label encoding again. Okay, label encoding and get the nominal data. Okay, So again, if you want to move from nominal to numerical, you want everything to numerical, you use one-hot encoding. Okay. So one-hot encoding is the key if you have categorical data to convert it to numerical data. Okay. For the ordinal data, there is this relaxation. There is something nice, which is that converting them by labels in the ordered way, because ordinal data you can order it. So you can use that order and convert it to labels based on that order, and then what you get is a numerical data. Okay. So that's about the encoding. Now scaling is a slightly different, not slightly, it's altogether different idea. Here you are converting a numerical column to another numerical column. But what we're trying to do is we're trying to somehow remove the effect of the scale of the numbers. Okay, and we took the example in the last class where we had two columns. One column could be ages, the other column could be salary, and the values in the salary column could be very high compared to the ages. And for the method, both columns, the meaning, the salary and ages may not mean anything. And looking at the numbers, some of the methods actually, you will find some methods for the scaling doesn't matter. But then there are some methods for which the scaling matter. And they might give high preference to high numbers. So they might give high preference to salary than to the age. So things could happen. So you need to do scaling. So you could do scaling where you take the old data and then you convert it such that the mean is 0 and the standard deviation or variation is 1. This is called as standard scalar. Okay, this is called as standard scalar. In Python, it is called a standard scalar. You could also have the old values and then you convert it to values where the minimum value is 0 and the maximum value is 1. So it's kind of a scaling. And this one you call it as min max scalar, min max scalar. And then you could also come up with your own way of scaling. For example, you want everything, let's say, in homework to be out of 100. So that's a scaling. You know, somebody could grade it out of 200 and then rescale it out of 100. And in general, you could have many types of normalization. Okay, and you have big area itself about normalization. But for us, we focus on these two scalings, the simple ones. One is the scaling where you have mean 0 and standard deviation 1, which is standard scalar in the language of terminology of Python. And then the other one is the min-max scalar, okay, min-max scalar. So the case study 2 is focused mostly on these, how to do the encoding, how to use the label encoding or one-hot encoding, or you could come up with your own custom encoding. Okay, this is also something that we'll see. Okay, you could come up with your custom encoding, or you could do the scaling, the usual ones, the standard scalar and min-max scalar. Okay, so these are the things that we'll be looking at in case study 2. Any doubts, any questions before we proceed?
Can you explain the standard scalar again?
The idea of the standard scalar is you take the column and convert it in a way that the mean, if you take the mean of the converted column, it will be 0, and the variance or the standard deviation of that column will be 1. So how it's done, you take the old value minus the old mean, okay, divided by the old sigma value. And when you do this step, what you will get is a new column with 0 mean and unit standard deviation or unit variance. Yeah, sigma is standard deviation. That's right, Hamza. Sigma is standard deviation. Okay, sigma is standard deviation. And mu is mean. Okay.
Okay.
Any other question? Any comments? All right. So if you have no further questions, let us jump to the case study. Okay. So in this case study, you are given with the data, which is in this file, data2.csv. And for this case study, we need to do the following. So let us do all these tasks one by one. The first task is to read and display the fields of the data using the Python pandas library. Of course, this is the only one. If we change this, then you will have to learn many other things. Okay. So that's the data. Using the info, I'm getting the information about all the columns, the name of the column, if there is any missing value, no. And then I'm also looking at the data type that is understood by the Python. So it's taking age as integer, balance as integer, and everything else is categorical. Okay. Maybe it is true or maybe it's not. And to check whether it's true or not, you could just go with the check the head of the data frame or any random number of rows. Okay. I know there are many ways. If you want to look at the first 5, you just write head. If you want to look at the last 5, what will you do? If you want to look at the last 5 rows, how will you proceed? Yeah, you go with the tail. If you want to pick any random 5, how will you do that? Yeah. Okay. But for sample, you have to mention the size. Otherwise, it will not work. Okay. So that's different ways to look at the data to get a glimpse of the data, and this will also tell us whether what Python understood is right or not. For example, age, yes, I can see its number. It is number. Job, marital, education, default, all of this should be categorical, and yes, it is. Balance should be numerical. That's true. Housing, loan, subscribed, all of them categorical, and that's true. So now I know that what Python read and what is actually what the values are is the same. So there is no inconsistency. Okay. If there is inconsistency, then you have to use the lambda apply lambda, and do the string or typecasting or whatever to fix it. Now the next task says identify an ordinal field containing 3 or more categories. So it has so many categorical, or you can say non-numerical fields. From with this, we would like to identify ordinal fields. So what I did, I calculated the number of unique values for each column. Okay, so let us do this one by one. Copy this. So when I do it like this, data frame.select data types object, I get non-numerical columns. And if I want the summary of these, okay, you could say now the summary of non-numeric columns, this is another style of getting the summary of non-numeric columns, will give you this row that tells you what there are 12 unique values in the job field. There are 3 unique values in the marital field. There are 4 unique values in the education, so on and so forth. Now I could read from here, or I could be very precise. I could say, no, I want only this row. And remember, this is .describe will give you a data frame. You see, it looks like a data frame. So from a data frame, if I want to get that particular row, what are the different options to extract a row from the data frame? You could use iloc or loc. Here, which one is easy? Well, I could use the name, and then loc will be easy. Otherwise, I have to say 0, 1. That maybe is also easy in this case. Okay. So here I am using the row unique, and what about the columns? Well, I want for all the columns. Then, yes, that's right, Hamza. Then I will get this. It shows that there are 12 unique values in job column. In marital column, there are 3 unique values, so on and so forth. So based on the criteria, these are the ones that have 3 or more categorical values. Now we need to see which one of them are really ordinal. Ordinal means the one that have order. So let us focus on job, marital, and education. So here are the columns. You have job, blue collar, unemployed, technician, student, management. Can you arrange them in order? Most probably, no. Then you have a column which is marital, and the values. If I want to know what are the different values in marital column, how to do that? I want to know what are the different values in the marital column. How to do that?
Isn't like the same thing as the one up top instead of unique and okay, wait. Do you mean like
Okay, value counts can be done, but I just want to know what are the different unique values in the marital column. Okay. Yeah, Hassan gave me the right answer. So here you just type, for example, marital dot unique, and this will give me all the unique values. So I have these values: married, single, divorced, divorced. Again, I cannot arrange them, so it's not ordinal. Okay. Then we have the other one remaining, which is education. Well, for education, you have primary, secondary, tertiary, and unknown. So, except unknown, which is any missing, you can say, or not known, everything else is ordinal. So you know that secondary educations come after primary education, and tertiary education comes after secondary education. So you can come up with an order. So the only field which is being asked here, the only field which is ordinal and have more than 3 categories is education, and these are the categories. Okay, primary, secondary, tertiary. Okay. Now let us look at this. Now he says for the education field, the one that we identified just now, convert the categories to the corresponding numerical values as follows. Okay, so for some reason we have now ordinal, and if you want to convert the ordinal column to numeric column, you could just come up with new labels. Okay, you can come up with new labels. So here this is what it's saying. It's saying for primary, wherever I see primary in education column, it must be replaced by value equals to 1. Wherever I see secondary in column, it must be replaced by a value 2. Wherever I see tertiary in the column for education, it must be replaced by value 3. And any other value which is unknown, for example here, should be deleted. Okay. So these are the things that we need to do. All right. Now to delete rows or columns, and if you want to delete NaN values, what's the method? If you want to delete NaN values, what's the method? Drop NA. Okay, data frame dot drop NA. Now in the beginning of this class, or while we're discussing this method, somebody talked about drop method. So drop method is a general method that can be used to remove rows or columns from the data frame. Okay, to remove the rows or columns. If you want to remove the rows, you have to use the index keyword argument. If you want to remove the columns, you have to use the columns keyword argument. Also, by default, it will be rows that will be deleted. If you want to delete columns, you have to change axis equals to 1. Okay. So there are different ways to use those keyword arguments. Okay. So here we are trying to delete the rows. So how to delete the rows? Well, to delete the rows, we have to catch the index. Please remember this. To delete the rows, we have to catch the index of a data frame. Now, how to get the index of a data frame? Let us start with this. How to get the names of the columns? If you write data frame.columns, you get the names of the columns. Similarly, if you write the data frame.index, you get the index of the data frame. Okay. So for example, let me get the slice of the data. I don't want to type, so I could write it here. So what are these true, false? What is this mask? This mask corresponds to
if it's unknown or not?
Yeah. So if you see anywhere here true, it means education is unknown. Otherwise, it's false. Now, when I have a mask like this. Okay, if I give the data frame single brackets, it gives me those rows. Okay, so this is also shortcut for catching the rows. Otherwise, I could have done like this: dot lock this comma this. Okay, mask is very flexible. If you want to catch the columns or rows, you could just give that mask directly. You don't have to use dot lock. Okay, you don't have to use dot lock all the time. So here's the shortcut. We give the mask in this, and you get all those rows that have education unknown. And now for this data frame, I want only the index, because this is enough for me to drop. So I could say dot index, and then these are those index where, let me just show you again, 20, 27, 49, 20, 27, 14, and so on. Okay, so this is a list, we can say the array, okay, that contains all the index values. So once you have this index, let's say here, for example, I'm calling it by this letter, by this name, index row. So now I have this in the index row. Okay, now I could say data frame dot drop, okay, index equals to index underscore row. Now, if I don't give index, by default it will take as index. Okay. If not, if it is the columns that I have to delete, then I have to be very careful. I have to mention columns. Otherwise, it will give index. And then you could see the data frame. And if you see here, for example, if you try to, well, you have only top 5 and bottom 5, but you should not see. It's also consecutive, but if you search in this data frame, let me type here XX something, okay, and now if you see in this data frame XX education dot unique, should not see unknown because the unknowns were deleted. Okay, now that's one way to get rid of the unknowns, the rows that contains unknowns from the data frame. I don't want to create the data frame every now and then. So either I could say data frame equals to this, or like other methods, you have the option in place equals to true, capital T. Okay. And this will make sure that the data frame has actually, cleaned. And then you can say, for example, something, data frame education dot unique, and it will give me the same. Okay. So that's how we remove the row. So again, to delete a row, you have to cache the index. Okay, and then you can use a drop method to delete those rows. Okay. All right. So we're done with the task 3. Half of it we actually did this part. Now we have to do the conversion. So wherever you see primary, it should be 1. Wherever is secondary, it should be 2. So on and so forth. So whenever you have such manual conversions, the easy way to do is to create a dictionary where the keys will be the old values and the values of the dictionary will be the new values. So for example, here primary is the key which correspond to the old value, and I would like to replace primary with 1. Similarly, I would like to replace secondary with 2. I would like to replace tertiary with 3. So that's the dictionary that I created, and then you select that column where you want to apply this dictionary, and you say dot map. So maybe at the beginning when we're discussing dot apply method, we talked about this dot map. Somebody said apply could be same as map. So apply and map, they are different for data frames, and this is the place where we can see how they are different. Okay, so data frame for a particular column, dot map is now replacing the old values with the new values, and the old values will be the keys of this dictionary and the new values will be this. So after this step, when you execute, you will see that the education now has different values, 1, 2, 3, 3, 2, corresponding to primary, tertiary. By the way, unknown is gone. No, it will be in that order. Okay, it will be in that order. So primary, secondary, tertiary, and then secondary, and so on and so forth. So data frame column dot map. Okay, once again, dot map is for replacing old values with the new values. It is like a sort of mapping. It is like a mapping where you replace the old values in the column with the new values. Any doubts? Any questions? Any doubts? Any questions? All right. Now you have scaling. So in this question, it asks you to select the age column and normalize it such that the max value is 1 and the minimum value is 0. So you're doing the min max scalar. So all these scalars, and we'll see some of the encodings, by default is part of a new library, which is sklearn, skykit-learn. Okay, it's also very standard library for data science. So you have seen pandas, you have seen seaborn. Pandas for handling the data, seaborn for visualization. For the analysis of the data, you have skykit-learn. In short, sklearn. Skykit, in short, sklearn. In the skykit-learn, you have this pre-processed. Actually, skykit-learn has so many modules, and probably you will be looking at them from now onwards till the end of this course. Okay, so skykit-learn will have so many modules. So the one that we would like for the scaling encoding is part of pre-processing. So from skykit-learn dot pre-processing, or from sklearn pre-processing, you're going to import min-max scalar. So there is a scalar already that does this min-max scaling, and that's why the name min-max scalar. Okay. Now, whenever you have anything to do with skykit-learn, always the same style. First, you import the class. Okay, so min-max scalar is a class, and then you create an object. For example, from the min-max class, I'm creating a min-max scalar object. So that's the scalar object, and then always this will be the step. First you create, first you import the class if it's not imported, and then you create an object, and then you fit the object. Okay, how to fit the object? You take the same name, whatever name we gave here, dot fit. Okay, dot fit will fit that scalar object. So basically it's trying to learn from the data. Okay, so dot fit means it's trying to learn from the data. So what is the data? Well, it's just this column age, because that's what we would like to use. So now after this line, what will happen is this scalar, this object, knows important things about this data. For example, you remember what is this min-max scalar? Anybody in the class? Do you remember what is this min-max scalar?
It's when you make the minimum value 0 and the maximum 100.
Yeah, so it will take all the values and convert it to 0, 1. So if this is the old value, if x is the old value, how do you do that? You do it by this. From there you subtract the minimum value divided by the max value of the column and subtracted by the min value. Okay, so that's the max value of the old column, that's the minimum value of the old column, and minimum value of the old column. Knowing these two, max value and min value of the old column, give me any x, I would do the conversion, and then the value will be between 0 and 1. So when you do the scalar dot fit, at least for this scalar, I could say that all it's doing is it's trying to remember these values, x min and x max. Now the scalar has this information, what is the min and max, so that if I give him any new value, any x naught, it will convert it based on this min and max to something new. Now if you want to convert a given column, then how do you do that? Well, you have to use scalar dot transform. Okay, scalar dot transform, and give whatever column you want to give here. Okay, and then it will convert it, then it will transform it. So scalar dot fit, it just learns whatever is required from that column so that it will scale. so that it can do the scaling. And then scalar.transform will actually do it. Okay, and this is almost similar to all the classes that we are going to get from sklearn pre-processing. First, we are going to create the object, then we are going to fit, and then we are going to do whatever is the processing that needs to be done. So here it's only transformation, but in other cases you will see some other tasks. Okay. So any doubts, any questions on this min-max scalar about sklearn pre-processing? Any doubts, any questions?
Yeah. What if we did? What if we didn't do the fit? Will it just not work?
It will not work because then he will never learn what is the minimum or max value from the column. From the column age, it will never know what's the min and max. So then it will not transform. Okay.
Okay, thank you.
Yeah. So the job of fit, the job of method fit is to learn from whatever data we gave as input. So for example, here I gave this age column as input. So when I gave this age column as input, the job of fit will be to learn whatever is required for it to fit. For example, for min-max scalar, what is required? The min value, the max value of that column. So scalar.fit will now remember min and max value. Okay, and then when you actually do the transformation, it will apply this formula for each value to get the transformed value. Okay, so far we didn't execute this. So go ahead.
This only works with the numeric columns.
Well, you have pre-processing for numeric and non for all, but min-max scalar is only for numeric. Remember our discussion here. Maybe I deleted the fonts, but let me show you something. Not this. Yeah, this one. So here you have scalar, standard scalar and min-max scalar. They are for numeric columns only. Okay, these two are for the numeric columns only. Numeric columns only. Whereas the encoders are for categorical columns, ordinal, and related. Okay, so the min-max scalar and standard scalar are for numerical columns. So it converts from one numerical to another numerical. Okay.
Yeah, okay.
Right. So I was using this. Yeah. So now, if I execute only this and type, or just type scalar, okay, it says it's a min-max scalar. Just that it's an object that we created. Now, if I execute the fit and see what's inside, well, it should show. So let's say print, or maybe. How about, well, there was a way to see what's inside it. That's the type. Okay. Well, maybe I'll let you know in the next class how to get. But once you fit the feature, it learns something from the data, and you can see it. Okay, you can see it, and maybe there is a way. It's not popping up in my head now, but yes, there is some way to see what's inside it. But once you learn from the data, then you can transform it like this. Okay, scalar dot transform this. Okay. Now, let me highlight something. If you see inside, what is this?
Name of the column.
A column.
Well, this is not just column. Something to look about. This is not just column. Okay. So what did I do? Okay. This is the column, okay? That's the data frame age, okay? That's a column. Now, most of the methods in sklearn, they don't want to have a column of the data frame. All they want is these values. All they want is these values. So how to obtain those values? Well, one way is to say, for example, values and get those values, okay? The other way is to use the double brackets. And this will give, oh, sorry, my bad. So this one gives you those values, okay? This one gives you those values. To extract the values, you could use values and you get the array, okay? For fitting, you want the values to be like a data frame, okay? You want the values to be like a data frame. So I got confused. So the values to be like a data frame. And this is how you can get. So instead of a column, now it gives like a data frame, okay? Instead of a column, it gives like a data frame. So that is the input to the scalar.fit, okay? So this is different from a column. Please remember this. This is different from a column, okay? And maybe type will show the difference. Let us see. Yes, I think type will show the difference. So if you pick a column, type will show that it's a series, okay? Now the other option that we have here, it will show it's a data frame. So for scalar.fit, data frame should be the input, okay? So that is why here we are giving data frame as the input. Please remember this, okay? If you give the other way around, you might get into errors, okay? So please remember this. When you have data frame for a single column with double square brackets, it will keep it as a data frame. It will not keep it as series or array, okay? So once again, if you have a data frame, if you want to get the values of the column, just the values, okay, we will use this dot values to just to get the values of the column. That will be like a numpy array, okay? If you do like this, what you get is a single column of a data frame, which is series, which is a series. Remember, data frame is collection of columns, or each column is a series. So data frame is collection of series. Now, if you want to get single column as a data frame, then we do it like this. So this is a data frame, a single column as a data frame, right? So that is the input that is needed for both fit as well as transform. Then you get the transformed values. You see the values are the output. To fix the values into our data frame, you do the reassignment. For example, here, yeah, here I'm doing the reassignment like this. I'm doing the reassignment like this. And then if you look at the data frame, let us print the data frame, and you will see that all the values in that age column has now been changed to something between 0 and 1. Okay, so that is how you do the min-max scalar. Any doubts, any questions? Any doubts, any questions? Especially this, okay? This is to send the data frame as a single column, okay? Single column with the structure of data frame.
What happens if we send the column and not the data frame?
Yeah, basically mean to send the column as series, right? If you do that, it will throw an error, and even if it does, it might do with some error, okay? It requires it to be a data frame. So if we give it as a, for example, you can try this now. If it accepts, it might take that as so many columns, okay? Or it gives you error. So for example, here it gives you error. It says that it is not possible. Either you make it in a column format or do some other approach, okay? So it's not accepting it.
Okay.
Okay, all right. Now on the same lines, you have standard scalar. So here we have another column in this task. We have another column called balance, which is numerical column, and you would like to scale or normalize the column such that the mean is 0 and the standard deviation is 1. So this is the other scalar, okay? And we call that scalar by name standard scalar. Why? Because that's the name of the function. So the same step, exactly the same step. First you read the class, import the class, sorry, and then you create the object. You could give any name here, actually any name here could be used. I use a different name just to avoid the overlap, okay? And then you do the fit, the same approach. You send a single column data frame as input to scalar.fit, and then you do the transformation, okay? Everything is same. The only thing is here you have min max scalar, and here you have standard scalar, and it does the same steps. And these are the temporary changes, and by reassigning the column we make the change permanent, okay? So the same idea like min max, you have standard scalar. Now similar to that, similar to standard scalar and min max scalar, you also have what we call label encoder. Label, it's an encoder, it's not a scalar, okay? This is encoder. So what it does is take categorical value and convert it to some nominal value, okay? It takes a categorical value and convert it to nominal value. For example, here we have the subscribed column, okay? And what do we have in the subscribed column? In the subscribed column you have yes or no. You have two values, yes or no. So here I just want to give a number to yes and give a number to no. What the label encoder will do is it will take all the values and arrange them alphabetically. So no will come first and then yes. And now automatically it will say no as 0 and yes as 1. That's it. So if you have so many, if you have, let's say, married, single, divorced, then it will do alphabetically, divorce, and then I think married, and then single, okay? And then automatically this will be given 0, this will be given 1, and this will be given 2. So that is the label encoder. That's the label encoder. It takes the unique values, arrange them in alphabetical order, and then assign the values. Yes, Hamza?
Uh, can we change it? Like, what if we want to make M 0 or something else 0?
If you want to come up with your own custom, you do the mapping like here, okay? You can do the mapping like here. For example, here I want primary to be 1, secondary to be 2, and tertiary to be 3. If you want to change, yes, you can create such dictionary and do the mapping, okay? Yeah. Otherwise, if you want to go with the alphabetical order, then you use the label encoder. All right. So the label encoder is again exactly similar to what we had done before. The only thing is it works for categorical columns. It works for categorical columns, and it does this assignment in the alphabetical order. That's the thing to need to remember. So the same steps, you see here, I'm calling importing the class, then creating the object. I can use the same name like scalar 2 or scalar, but I'm using a different name here just for my easiness. And then I'm fitting and I'm sending the column, but this time I just send it like a column, not like a data frame, okay? Not like a data frame. I'm just sending the column here, okay? And then I'm doing the transformation. Again, it just requires a column as a series, not as a data frame, and that's it. And then you have the changes. And to see the changes, you could look at the unique value. For example, here, if I look at the unique value, I see I get 0, 1, where 0 corresponds to no and 1 corresponds to yes. It's alphabetical, okay? It's alphabetical. Any doubts, any questions? In these three simple encoders, you have min-max, you have standard scalar, and then you have label encoder. Any doubts, any questions? Okay, so if not, we'll move to this bullet number 7. Here you have a categorical column, which is marital, which is here married, single, divorced. And we would like to do one-hot encoding. So what is the idea in the one-hot encoding? It is going to create new columns. So one column for married. Well, it's going to do again alphabetically. So one column for divorced, then married for single. And whenever I see a married, I'm going to write here 1. Okay, so let's make things easy in the same line. Divorced, married, single. So if it is married, I'm going to write here 1. If it is married, I'm going to write here 1. If it is single, I'm going to write under the single 1, and for married here. Okay, same thing here. All of them are married except the last one single. And everything else here will be what?
0.
It will be all
0.
zeros. Yes, it will be all zeros. And that's it. This is one hot encoding. So what it will do is it will delete this column. That's the thing to remember. It will delete this column and it will replace this column, and sorry, it will delete this column and it will add 3 new columns, or as many new columns as the number of unique values. So if here you have 10 unique values, you will have 10 new columns. Now one thing to remember is when you have these columns, one of the column is redundant in the sense we don't need that column. For example, if I have any 2 columns, if I have let's say 0 here and 0 here, what does it mean? It means it is 1 for the single for sure, right? There is no way that it must be one of these 3, because that's how we got here. We have 3 categories: divorced, married, single. So if there are 2 zeros here, that means the third one must be 1, right? If there is a 0 and 1 here, what should be the third one?
0.
0.
For sure 0. Okay. Similarly, for one of the rows, if you have here 1, then it must be 0 here and 0 here. So you see, not all the 3. If you have 3 categories, not all the 3 are needed. Actually, one of them can be removed and still you will have the same information. And usually you want to have less number of columns. So that's why a standard way is to pick the first column and remove it. Okay, to remove the first column and then have all the remaining columns, because this will be enough to have the same information that we have here. All right, so this is the theory. Now maybe in 1 minute I will finish. Let me just continue and I'll finish. So how to do this in Python, in pandas? Well, you have a method called get dummies. Okay, you have a method called get dummies. So pandas.get dummies, you give the data frame, the entire data frame as input, and then you say for which column you want to do the one hot encoding. You could do it for one column by writing one column name here, or you could do it for multiple columns in a single shot. It's your choice. So here I'm just giving one column because that is what is asked here. Okay, one column here. And then if I want to drop this first column, okay, if I want to drop this first column, then I'm going to use this option. Why? Because having less columns is always preferred. So I know one of the columns is always extra redundant, and deleting the first column is usually done. And to delete that first column, we say drop first equals to true. Okay, by default it will drop this column. By default this column will be gone, because we always want to have less number of columns. So this column is by default gone, and to delete this one, we have drop first equals to true. And once you execute this, this is what we get. That column of marital has been gone. Okay, that column for marital has been gone, and we got 2 new. There was supposed to be 3: marital underscore divorced, marital underscore married, and marital underscore single. Okay, but the first one is gone. If I want to keep that one as well, I'll just remove this. I think I cannot do it multiple times. So just a second. Let me run this and let me go back and yeah, here. So now you see you have marital, divorced, married, single. So if you don't give that option, it will give you all the 3. If you want to remove one of them because it's redundant, we can use this option. Okay, and then you will have this column converted to one hot encoded column. Okay. All right, so let us stop here. I took a couple of extra minutes, but I think we were in the middle of discussion. So let us stop here. If you have any questions, any comments, you can ask now.